In this lesson, I'll introduce you to PSoC Creator. PSoC Creator is Cypress's integrated design environment. It's the tool that helps you make a PSoC your PSoC. We'll talk about the unique design flow that will help you create your ideal PSoC. As we talked about in the PSoC Overview, PSoC doesn't shoehorn your project into a fixed function device. We allow you to specify your project needs and create a custom solution without a custom price tag. When you start PSoC Creator, you'll be presented with what we call the Start page. This is a web page. It pulls the latest news and information from Cypress.com. We try to keep it technical and relevant. From the Start page, you can find an example project or open a new blank design. I almost always choose to work from an example project, or perhaps from one of my previous projects. For this training, we'll start both from a blank schematic as well as from several example projects. In PSoC Creator, you can start off developing your PSoC device by choosing the features you want your processor to have. Write them out in a notebook or on a whiteboard, it doesn't matter. Then you can start by dragging and dropping components together to make a system that you never thought was possible in a single chip solution. I tend to start with the example project of the cornerstone peripheral I'd like to have in my design. Perhaps the CapSense or an LCD controller. Really, whatever feels like the most important part of my design. I get that set up and working the way I'd like. Then I expand to additional components. Often, I'll just drag them in and start configuring them. Other times, I might open the example project in the Explorer window and copy in some code. After that first major block, I typically start with the communication peripherals, the UART, or the USB, or the I2C. Then I move on to the interfaces like the LCD or the TMP05 temperature sensor. The exact order of adding these things is up to you and the way that you think. PSoC Creator is here to enable you to drag all of the components over and start wiring, or to drag each individual component, set it up, write its code, and then move on. I'm somewhere in the middle of these two. I like to define my system into subsystems and then get each one working at a basic level. Once I have the basics of my system running in the schematic, I start customizing the interactions between the components. Then I move on to setting up any discrete logic to totally customize my solution. The components you're dragging over onto the schematic are more than simple icons. PSoC Creator has over 120 components today, all tested, all verified. These components range from your typical communication peripherals like UARTs, USB, and I2C to low-level AND gates, OR gates, NOR gates. They include analog functionality like op-amps, trans-impedance amplifiers, and del-sig ADCs. We even have system-level components for fan control and system management. I won't go through all 120 components. You can easily do that with our component catalog. Each component has a detailed datasheet, which is accessible via the context-sensitive menu in the catalog. I just wanted to give you an understanding that there's a lot of functionality available to you with the components PSoC has available today. Moreover, my team is continually developing new ones, which will be available in new releases. PSoC is the only solution where day after day, month after month, and year after year, the functionality will increase for the silicon you've already purchased. Components really are what make PSoC PSoC. You drag and drop them onto your schematic, then you customize them with the component configuration dialog, creating a custom PSoC. That means the IP is only as big, with only as many features and using only as much power as you need. We reserve the remainder of the system resources for the rest of your application. Once you have all of the components on your schematic, you wire them up with any discrete logic that you need. Then you identify the pins. This is another unique feature of PSoC. On a PSoC device, you have a significant amount of flexibility to route your internal signals to different pins on the device. This will help you make a cleaner system on your board, or perhaps save you from a board respin when you cross the transmit and receive lines, though I'm sure none of you have ever done that. Each component has a configuration dialog, basically a set of screens that help you set up the component to your specifications. You double-click on the component icon and the component configuration dialog will open up. This is where you set the baud rate on your UART or how many channels you need on your MUX. From each dialog, you can directly access the component datasheet, a short document that gives you the specific electrical and functional information for that component. This will help keep you from digging through the 2,000-page TRM. You really should read each of these data sheets. Each has the setup information as well as any tips for the particular component you're using. They also have the list of APIs for each component. I don't like reading manuals any more than you do, but these really will help you keep from making mistakes. When you build your PSoC Creator project, the tool creates a full set of tested APIs for every component. You don't have to memorize the registers and their locations. You just call the simple APIs and we'll take care of the register details. With the autocomplete feature in the editor, you don't even have to memorize the APIs. We'll talk more about these generated APIs as we go through the blinking LED and the CapSense projects later on. Once I have gotten my schematic design and components set up for a subsystem, I'll start writing my C code. The editor in PSoC Creator is good for many application projects, but I know that many of you may be more familiar with one of the ARM tools and their particulars. That's why you're able to export your project into IAR or Kyle or Eclipse directly from PSoC Creator. Mark will go over the export process to each of these IDEs in a later lesson. In the PSoC Academy, I challenge my coworkers to write a Simon Says player to compete with my master controller. It's a fun project, but the thing that amazes me the most is just how different the problem can be solved by each team. I've seen a whole, working, winning system with as little as 3 lines, yes, 3 lines of code that the team wrote for themselves. They did everything in hardware along with the generated code. I've seen other teams who wrote pages and pages and pages of code, and that works as well. Most of the teams end up somewhere in the middle. They use hardware interrupts to offload the processor, and then they write a bit of code to customize the CapSense buttons. When you use PSoC, you can use our hardware and software in whatever mix works best for your problem. The PSoC solution really does let you design the way you think. That's the basics of the PSoC Creator design flow. Start your project, drag in your components, configure them, wire them together, then write your firmware. That's it. In a future training, we'll go into some of the advanced features like generating custom components, where you can take a working subsystem and make it into your own component, your custom IP with our chip. Thank you for watching this lesson. I hope you've learned a bit about PSoC Creator. This is the last overview of the PSoC solution. In the next lesson, we'll get technical and start blinking an LED on the PSoC 4 Pioneer kit.